I made a couple upgrades to my dog treat robot. So I added a solar charger in the back here. I still use, as you can see, quite a few batteries as well, but those are all rechargeable. So this is definitely a green dog treat robot. One of the issues that I was facing was that little Pixie camera. I don't know if you can see it in the front. It's really good for doing things like object tracking, so I'll give you an idea there. But it's only sending coordinates to my Arduino, so it's not sending an actual like video stream. Unless I have it plugged into my computer via USB. But that, you know, if I want to drive around my robot, I don't want it plugged in. So let me get that out of the way. It's kind of cool. So what I did was I added this ESP32, which is a chip that can host a web server, and it's much more flexible in what types of data it can send. So I can send video data, and then I don't know if you can see it, but there's a 2 megapixel camera I attached directly to that chip. So now in my Android app for my robot, I actually have a video feed, which is kind of cool. There's some lag, right? But the nice thing is that since it's hosted on a web server, it's like kind of like a website basically. Hypothetically, I could access my robot from anywhere in the world now. So if I'm traveling and want to give George a treat, I could do that. And there's some controls. So, in addition to that, one of the challenges I was facing was around controlling my LEDs, or more specifically RGB LEDs. So each one of these little lights here actually has 3 chips in it, and each one of those chips is a color, and then you mix those colors to, you know, create any other type of color. And where I was getting a limitation was on this Arduino Mega microcontroller. I was using all of its PWM pins to control my servo motors on my robot arm. So I didn't have any of that pin type to use for my LEDs. And what I did was I found online a chip that kind of acts as an expansion board for different types of, like specifically actually PWM pins. And then I was able to attach each one of these pins to each one of those legs on the LEDs. So then I can independently control each one of the LEDs. So now, like for example, when I go right, it turns green. When I hit stop, it turns red. You know, pretty important safety features for a dog treat robot, in my opinion. In addition to that, I went ahead and added voice controls too. So I'll show you what that's like. Blue. Right. Yeah, that's pitch high.
Is my pitch high enough?
Yeah, there we go. Green.
Green.
What is your favorite holiday?
Christmas is my favorite holiday because I enjoy giving out treats much like Santa gives out presents.
Pretty cool. And then I can also do like, give George a treat.
Give George a treat.
It automatically kicks off the robot arm to go into the treat giving mode. It's not aligned right here. My servo motor that controls the rotation of the arm burnt out. I have to update that. Upgrade it rather. but you can imagine how useful that will be. Pitch low. Oh, thought I said Mitch low. Pitch low.
Is my pitch low enough?
Oh yeah. Forward.
Forward.
Demo.
Demo.
Then I can still, hold on, let me turn it around. Oh. Then I can still use this potentiometer that's kind of buried right now to control the speed of the arm. So I created a floating variable in my Arduino code that's based on where this potentiometer sits. And then that inputs the delay into the code that is actually executing all the movements of the arm. So now, like, let me turn it down and I'll do the dog treat one. So, give George a treat. Oh, I thought I said give him a tree. The robot cannot cut down trees yet, so. Oops. Give George a treat.
Give George a treat.
So it should go a lot slower. You can see that. Since I slowed it way down. That's maybe a little too slow. But yeah, the self-driving mode still works pretty well too. That can almost be, layered on top of all these other new functions. George isn't super impressed.